An ion is an atom that has lost or gained one or more electrons. And an ion is just a charged atom, or an atom that has lost those electrons, so it has a different charge than just a neutral atom. The octet rule, and oct means 8, states that atoms will lose, gain, or share one or more of their valence electrons to achieve a full outer shell. There's two types of ions. There are cations, which are the positive ions. And a lot of people will remember that a cation is positive because if you write it out with a T as a big plus sign, it is a positive ion. Sorry, that's a little bit off the screen there. So things you need to know about cations is they are positively charged ions. They are usually metals. So they're on the left side of the periodic table. They're positively charged, and they have lost one or more electrons. That's my dog jangling around. I don't know if you can hear her or not. So if you look at a periodic table, on the left side of the periodic table, that's where you'll find the metals. So there are things on this side of the periodic table that you're familiar with, like iron and gold and silver, things like that. These are the things that form cations. Sodium's one. Hydrogen is a strange one because it's not a metal, but it's on that side of the periodic table. Anions are the opposite of cations. Anions are negatively charged particles, and they are nonmetals. So they're on the right side of the periodic table. And an means not or negative. So these are negatively charged particles because they have gained electrons. So they have a few extra, maybe one or more extra electrons in their outer shell. So this graphic is a little bit difficult to see over here, but let's just talk through it. So on the left side of the graphic here, you'll see cations, which are positively charged, and their atoms. So because they're losing an electron, the positive charged things are smaller than the just plain old atoms because they've lost an electron in their outer shell. So cations are smaller than their atoms. And you need to know the reason for that is that they've lost one of their electrons. Anions are bigger than their atoms because they've gained an electron. So over here you can look at the example of chlorine. So chlorine on this side, that's the atom, and it's represented by this little half sphere there, is smaller, and the chloride ion is a whole lot bigger. So lithium, which is right here, forms a cation with, you can see it right there, it's got a positive charge. And fluorine, over here in the other corner, on the other side of the periodic table, forms an anion with a negative charge. So charges can be determined by the element's column, or sometimes we call it family, on the periodic table. So here's a picture of the periodic table and the two different parts, and you can see things on the left side of the periodic table have a positive charge, and the things on the right side tend to have a negative charge if they're an ion. The last column of the periodic table has a full octet, so it is not interested in gaining or losing electrons at all. And this is really what drives all chemical reactions. So changing electrons from one atom to another helps form and separate compounds.